Good morning students. Previous class we have seen the 6 formulae under the heading some special integrals. Now let us see the 3 formulae. So I coin it as a 3 formulae for quick remembrance. So 3 formulae. They are integral root of a square minus x square dx is equals to x by 2 root of a square minus x square plus a square by 2 sine inverse x by a plus c. This is also remember it to be x by 2 a square by 2 formula. So do not be confused with the one which we have discussed in the previous 6 formulae. Those are 1 by root a square minus x square, that is sine inverse x by a. But here this is root a square minus x square dx. This is x by 2 root of a square minus x square plus a square by 2 sine inverse x by a plus c. So to be familiar with this formula, you have to be familiar with the integral 1 by root of a square minus x square dx. Second, integral root of a square plus x square dx, x by 2 root of a square plus x square plus a square by 2 sine h inverse x by a plus c. Earlier one is integral 1 by root of a square plus x square dx. The third one is integral root of x square minus a square dx. This is x by 2 root of x square minus a square minus a square by 2 cos h inverse x by a plus c. So x by 2 a square by 2, x by 2 into given plus a square by 2 into what is integral root of 1 by root of a square minus x square, sine inverse x by a, that we have to write here. So integral root of a square plus x square dx, x by 2 into given plus a square by 2 into what is integral 1 by root of a square plus x square dx, that is sine h inverse x by a, or log mod x plus square root of x square plus a square also. So this is how we have to remember, but for this actually we will be getting minus. So let us derive how we get there. So the first one, integral root of a square minus x square dx. Let x is equals to, what did we take before for proving integral 1 by root of a square minus x square dx? Sine inverse x by a plus c, for which we have taken x is equals to a sin theta. The same concept here also it is applicable. So x equals to a sin theta I take. Differentiation we get dx equals to a cos theta d theta. So now integral root of a square minus x square dx is equals to square root of a square minus x is a sin theta while x square is a sin theta whole square, that is a square sin square theta into dx is equals to a cos theta d theta, a cos theta d theta. So this is root of, take a square in common, 1 minus sin square theta into a cos theta d theta. This is equals to integral 1 minus sin square theta is cos square theta. 1 minus sin square theta is cos square theta. This is a square cos square theta under root. So a cos theta whole square under root. This is a cos theta into this is a cos theta d theta. So this is a into a square. Since a square is a constant, I am separated from the process of integration. Cos theta into cos theta is cos square theta. Cos square theta can be written as 1 plus cos 2 theta by 2 d theta. So this is a square by 2 also I'll take out from the process of integration. Integral 1 d theta plus integral cos 2 theta d theta. So a square by 2 integral 1 d theta is theta plus integral cos 2 theta is, let us suppose this to be theta. Integral cos theta is sin theta. So sin 2 theta by d theta of 2 theta is 2. So plus constant of integration c. So this is a square by 2. Theta value is here x is equals to a sin theta, x by a is equals to sin theta. So from this, theta is equals to sin inverse x by a. So this is what we have got so far. A square by 2 into, this is theta plus half, sin 2 theta is 2 sin theta cos theta plus c. So 2 gets cancelled. This is a square by 2 into theta plus sin theta. So from this, x by a is equals to sin theta. So x by a whole square is equals to sin square theta. So 1 minus x by a whole square is equals to 1 minus sin square theta. So from this, 1 minus sin square theta is cos square theta is equals to a square minus x square by a square. Therefore, cos theta is equals to square root of a square minus x square by root a square is a. So this is what we have got. Now this is equals to sin theta, in the place of sin theta, x by a into, in the place of cos theta, this is root of a square minus x square by a plus c. So this is equals to a square by 2. So theta is equals to how much? Sin inverse x by a. Sin inverse x by a plus, this is x by a into a is a square into square root of a square minus x square plus c. This is equals to a square by 2 into sin inverse x by a plus a square by 2 into x by a square into root of a square minus x square plus c. So a square gets cancelled. Therefore, we get integral root of a square minus x square dx is equals to x by 2 root of a square minus x square plus a square by 2 sin inverse x by a plus constant of integration c. Therefore, integral root of a square minus x square dx is equals to x by 2 root of a square minus x square plus a square by 2 sin inverse x by a plus c. Similarly, we can prove that integral root of a square plus x square dx is equals to x by 2 root of a square plus x square plus a square by 2 sin h inverse x by a plus c. So to get it, we have to take x is equals to a sin h theta, and whatever the trigonometric identities, hyperbolic trigonometric identities are there, so they have to be applicable here. Then we will be getting integral root of a square plus x square dx is equals to x by 2 root of x by 2 into given root a square plus x square will get here plus a square by 2 sin h inverse x by a plus c we will be getting. Let us see integral x square minus a square dx is equals to x by 2 root of x square minus a square minus a square by 2 cos h inverse x by a plus c. To prove this, let us take x is equals to a cos h theta, dx is equals to A cos h theta derivative is sin h theta d theta. Now from this x by a is equals to cos h theta. So theta is equals to cos h inverse x by a, and we have cos h square theta minus sin h square theta is equals to 1. Cos h square theta minus 1 is equals to sin h square theta. So sin h theta is equals to square root of cos h square theta minus 1. So this is equals to cos h square theta is nothing but cos h theta whole square. What is cos h theta? X by a. What is cos h theta? X by a. X by a whole square is x square by a square minus 1. This is equals to sin h theta. Therefore, sin h theta is equals to square root of x square minus a square by a square. Now this is equals to integral root of x square minus a square. Proof. Dx is equals to square root of x square is a cos h theta whole square. So a square cos h square theta minus a square into dx is equals to a sin h theta d theta. So this is equals to integral, take a square in common, cos h square theta minus 1 into a sin h theta d theta. So this is cos h square theta minus 1 is sin h square theta. So this is a square sin h square theta. So a sin h theta whole square, square root gets cancelled, we will be getting a sin h theta into another a sin h theta is there. So a square sin h square theta d theta. Again, I have taken a square in common in both of them. Then cos h square theta minus its quotient 1. Outside a sin h theta d theta is same. So cos h square theta minus 1 is cos h square theta minus 1 is sin h square theta. Therefore this is inside a square sin h square theta is there. A square sin h square theta is a sin h theta whole square. Square root gets cancelled. So a sin h theta into a sin h theta is a square sin h square theta d theta. So a square, the constant can be taken out from the process of integration into sin h square theta is cos h2 theta minus 1 by 2 whole d theta. So a square by 2 also I'll take outside, cos h2 theta minus 1 d theta. A square by 2 integral cos h2 theta is sin h2 theta by 2, its quotient 2 minus integral 1 d theta is theta. So the integration process is over. So this is a square by 2. Again sin h2 theta is 2 sin h theta into cos h theta by 2 minus theta. So 2 gets cancelled. A square by 2 into sin h theta is this square root of x square minus a square by root of a square is square root gets cancelled a. So for sin h theta I have replaced it as square root of x square minus a square by a square into cos h theta is x by a. So this is into x by a minus theta is equals to cos h inverse x by a, cos h inverse x by a plus constant of integration c. So this is equals to So this is equals to, this is a square by 2, this is a square by 2. So here this is x into root of x square minus a square by a into a is a square minus cos h inverse x by a plus constant of integration c. So this is equals to a square by 2 into x by a into square root of x square minus a square minus a square by 2 into cos h inverse x by a plus constant of integration c. So here this x a and this a gets cancelled. So here a into a is a square. So this is a square. This is also a square. In that case a square gets cancelled. A square gets cancelled. See, this a into a is a square. So a square by 2 into x root x square minus a square by a square. So a square gets cancelled. We are left with x by 2 root of x square minus a square minus a square by 2 cos h inverse x by a plus constant of integration c. Therefore, integral root of x square minus a square dx is equals to x by 2 root of x square minus a square minus a square by 2 cos h inverse x by a plus c. What if the integrand is the combination of two linear factors with one of the linear factor is under square root? That is evaluation of integral of the form integral px plus q by ax plus b under root dx, or px plus q under root by ax plus b dx, or px plus q into square root of ax plus b dx, or 1 by px plus q into square root of ax plus b dx. So wherever you see, you can see two linear factors with one of the linear factor is under root. So here the positions are different. So here px plus q is on numerator, this is denominator. Denominator has got the root. Here numerator has got the root. Here both linear factor are multiplying with each other. Here both are dividing, both are in the denominator and one being under the square root. In this situation, how to evaluate the integration? So simply, whichever the linear factor that is under square root, simply you have to take t square. We have been taking something is equals to t so far under the method of substitution. So instead of t, we have to take t square. That is, let ax plus b is equals to t square we have to take here. Here px plus q is equals to t square. Here ax plus b is equals to t square. So here also ax plus b is equals to t square. And we have to differentiate as usual. Then it will be automatically converted into the known or standard integrals. So let us write all the formula at one place before starting the exercise B. So these are the formulae we have learned so far. 6 formulae, that is integral 1 by square root of a square minus x square dx. This is x by 2 root of a square Since this is 1 by root of a square minus x square, this is sin inverse x by a plus c. Integral square root of a square plus x square dx. This is sin h inverse x by a plus c. Integral 1 by square root of x square minus a square dx. This is cos. Of course, this has got another formula which is log mod x plus square root of a square plus x square plus constant of integration c. Or so it has got two formulae. The third one is integral 1 by square root of x square minus a square dx. This is cos h inverse x by a plus c or log modulus of x plus square root of x square minus a square plus c. Integral 1 by a square plus x square dx. 1 by a tan inverse x by a plus c. Integral 1 by a square minus x square dx. 1 by 2a log mod a plus x by a minus x plus c. Integral 1 by x square minus a square dx. 1 by 2a log mod x minus a by x plus a plus constant of integration c. So these are the 6 formulae and 3 formulae or x by 2 comma a square by 2 formulae. So they are integral root of a square minus x square dx. This is equals to x by 2 into given a square minus x square plus a square by 2. What is integral 1 by root of a square minus x square dx? It is sin inverse x by a. So simply we have to write here sin inverse x by a plus c. Integral root of a square plus x square dx is equals to x by 2 into the given function you have to write here plus a square by 2. What is integral 1 by root of a square plus x square dx? It is sin h inverse x by a or this. So sin h inverse x by a plus c. Otherwise you may also write it as x by 2 root of a square plus x square plus a square by 2 into log mod x plus square root of a square plus x square dx. That is also another formula for that. And integral x square minus a square dx. This is equals to x by 2 into the given same we will be getting here x square minus a square minus, for these two will be getting plus, for this we will be getting minus. So we have seen this also in the derivation. A square by 2. What is integral 1 by root of x square minus a square dx? It is cos h inverse x by a. So this, or you may even write it as log mod x plus square root of x square minus a square plus c as well. So let us start the exercise 6b. Integral e power 2x dx. So we know what is integral e power x dx. So it will be converted into the standard integral formula if and only if this 2x has to be x, for which let 2x is equals to t I will take. Now differentiation 2 dx equals to dt. Therefore dx equals to dt by 2. So this is equals to e power 2x is equals to how much t into dx is dt by 2. So 1 by 2 I will separate from the process of integration. This is e power t dt. So 1 by 2, it has become integral e power t dt. It is nothing but integral e power x dx. What is integral e power x dx? E power x plus c. So this is e power t plus c. But this should not be the answer because the given integral is in terms of x. But here we are getting in terms of t. So replacing t by 2x back will be the final answer. So e power 2x plus c. So no need to do all these things. Simply this 2x you assume it as x. What is integral e power x? E power x itself. So x here is 2x by what is d by dx of 2x? 2. That is into 2 plus c. We used to do first actually we used to take 2x is equals to something in differentiation, and whatever that we have taken before we need to differentiate it. But here since the differentiation and integration are opposite processes, reversal processes, instead of into d by dx of 2x we need to do by d by dx of 2x, which is 2 simply. So all this process need not be done, so directly we can get it. And the next question is integral sine power 7x dx. So to do this problem we know what is integral sine x dx. What is integral sine x dx? What is integral sine x dx? Minus cos x plus c. So this will be converted into a known formula if and only if this has to be x. So this. So what do we do? Let 7x is equals to t. 7 dx is equals to dt. dx is equals to dt by 7. So integral sine t dt by 7. So 1 by 7 into integral sine t dt. 1 by 7 into what is integral sine x dx? Cos x. So what is integral sine t dt? Cos t. So 1 by 7 cos t. 1 by 7 cos t is 7x. So 1 by 7 minus 1 by 7 cos 7x plus c. So we need not do all these things. So only thing is let us assume this to be x. What is integral sin x? Minus cos. So minus cos 7x by what is d by dx of 7x? 7 plus constant of integration c. That's it. So in this way the substitution method is useful. Now the third question is integral x by 1 plus x square dx. So how do we do this? So seeing this we can understand that 1 derivative is 0, x square derivative is how much? 2x. But here we have x here. So for that let us multiply and divide by 2. Okay, so this is the question. This is the question. So for this what I am doing is 1 plus x square derivative is 2x. So I will multiply 2 and divide 2 by 1 plus x square dx. Now 1 by 2 into 1 plus x square is f of x. Its derivative is f dash x. F of x is 1 plus x square. What is f dash x? Its derivative, 1 derivative is 0, x square derivative is 2x. So 0 plus 2x is 2x. It is simply f dash x by f of x. We have already seen the results. Integral f dash x by f of x dx is log mod f of x plus c. Integral f dash x by root f of x dx is 2 root f of x plus c. Integral f of x whole power n into f dash x dx, f of x whole power n plus 1 by n plus 1 plus c. Okay, this we have seen. So this is integral f dash x by f of x is log mod f of x. So log modulus of what is f of x here? 1 plus x square plus constant of integration c. So if you are not familiar with the results, then let 1 plus x square is equals to t. This is an alternative, or the conventional process is let 1 plus x square is equals to t. Differentiate 1 derivative is 0, 2x, x square derivative is 2x, dx is equals to dt. So x dx is equals to dt by 2. So this is equals to, what is x dx? What is x dx? dt by 2. So 1 by 2 dt. So this 1 by 2 I have separated from the process of integration. dt by 2 I have written it to be 1 by 2 into integral dt by, what is 1 plus x square that we have taken earlier? T. So this is the form integral 1 by t dt. So we know what is the formula for integral 1 by x dx, log mod x. What is integral 1 by t dt? Log mod t. So this is 1 by 2 log modulus of t plus c. So 1 by 2 into log t has to be replaced by 1 plus x square to obtain the answer. So you may compare these two. So that's what I am telling you. The more you are familiar with the results, the more conveniently you can do the problem. Now the next question is integral 2x into sin x square plus 1 dx. So we have seen earlier that x square plus 1's derivative is 2x, right? So let x square plus 1 is equals to t. So if you So for this problem to be solved, so you must be familiar with both differentiation formula as well as integration formula. So you should not be confused as which function is to be taken as the original function and what is its derived function. So x square plus 1 derivative is 2x, not 2x derivative is x square plus 1. So if you know the difference between these two things, then actually you can do the problems easily. So let x square plus 1 is equals to t. Let us differentiate 2x dx is equals to dt. So this is equals to 2x dx. 2x dx is dt into sine, what is x square plus 1? This is t. So is it not of the regular formula? Integral sin x dx is how much? Integral sin x dx is minus cos. So this is minus cos t plus constant of integration c minus cos t has to be replaced as x square plus 1 to obtain the final answer. This is how we will solve this. Next one, integral log x whole square by x dx. So here we know log x derivative is 1 by x, for which let log x is equals to t. So log x derivative is 1 by x dx is equals to dt. So now this is equals to, what is log x? T. Its square is already there. So 1 by x dx is how much? dt. So we know integral x power n dx is x power n plus 1 by n plus 1. What is integral t square dt? T power 2 plus 1 by 2 plus 1. T cube by 3. T cube by 3 plus c. So what is t? So let's not forget to replace t by log x, because the given integrand, what is integrand? Whatever that is in between integral and dx, this is integrand. So this is in terms of x. Differential operator is also, differential quotient is also in terms of x. Therefore we have to replace t by log x. So this is log x whole cube by 3 plus constant of integration c. So the next question is integral e power tan inverse x by 1 plus x square dx. So you might be thinking, why aren't we using the results directly? Because tan inverse x is the original function f of x, its f dash x is 1 by 1 plus x square. Instead of that, actually the third function is also there, which is e power x. There are three functions, therefore one function is already there. So had it been the two functions, one is original function and one is its derived function, then the actually results will be useful. But here exponential function is there, inverse trigonometric function is there and its derivative is there. So therefore results cannot be used. Let tan inverse x is equals to t. Tan inverse x derivative is 1 by 1 plus x square dx is equals to dt. Now substitute e power, what is tan inverse x? This is t. 1 by 1 plus x square dx is dt. What is integral e power t dt? E power t plus c, because integral e power x dx is e power x plus c. Here in the place of x it is t. Therefore it is e power t plus c. So e power, what is t? This is tan inverse x plus constant of integration c. So the seventh question is sine of tan inverse x by 1 plus x square dx. We have already seen earlier that had it been tan inverse x by 1 plus x square dx, we would have taken tan inverse x is equals to f of x and 1 by 1 plus x square is f dash x. So we can use the results. But here there are three functions: sine function, tan inverse x and its derived function. Three functions are there. So let us go in a conventional way itself. Let tan inverse x equals to t. Tan inverse x derivative is 1 by 1 plus x square dx equals to dt. So this is equals to sine tan inverse x is equals to how much? T by t into 1 by 1 plus x square dx. 1 by, this is into, this is how much? This is sine into tan inverse x into, this is 1 by 1 plus x square dx, right? So sine tan inverse x is equals to how much? T. So sine t into, what is 1 by 1 plus x square dx? This is dt. So we know what is integral sin x dx. Integral sin x dx is minus cos x. Therefore what is integral sin t dt? Minus cos t plus c. So this is minus cos t is to be replaced with the tan inverse x to get the final answer. So this is how we will solve the problem. Integral 1 by 8 plus 2x square dx. So for this to solve, so we want x square quotient to be unity. Why I am telling this? So we have the formula integral 1 by a square minus x square dx, or root of a square plus x square dx, or x square minus a square dx. 6 formulae are there. These are a square minus x square dx, x square minus a square dx, 1 by a square plus x square dx, 1 by a square minus x square dx, and 1 by x square minus a square dx. In everywhere you see x square quotient is 1. So this is 1. So therefore I want this x square quotient to be unity, for which let us take 2 as a common factor. So 2 I will take common, then this is 4 plus x square dx. So 1 by 2 into 1 by, this 4 is 2 whole square plus this is x square dx. So 1 by 2 into, we know integral 1 by root of a square plus x square dx. This is 1 by a tan inverse x by a plus c. Okay, we know the formula. Integral 1 by a square plus x square dx is 1 by a tan inverse x by a plus c. So this is 1 by, this is a square plus this is x square. So in the place of a you see 2. So 1 by 2 tan inverse x by a. So x by 2 plus constant of integration c. This is 1 by 4 tan inverse x by 2 plus constant of integration c. Quotient integral 3x square by 1 plus x power 6 dx. So whose derivative is 3x square? Whose derivative is 3x square? We know x cube. the derivative of x cube is 3x square. X power n is n into x power n minus 1. So x cube derivative is 3x square, for which we'll write it as x power 6 as x cube whole square. A power n whole power n. A power mn, 3 2 is 6. Now let this x cube is to be treated as t. What is x cube derivative? 3x square dx is equals to dt. So now what is 3x square dx now? This is dt by 1 plus x power 6 is x cube whole square. What is x cube? This is t square. So this is 1 by 1 plus t square dt. What is integral 1 by 1 plus x square dx? Tan inverse x. We have the direct formula for that. So tan inverse t plus constant of integration c. So tan inverse t is equals to x cube. So this is how we will do the question. So the next one is 2 by square root of 25 plus 9x square dx. So like what we have done for the 8th question, x square quotient 9 is to be taken common, so that the x square quotient will be unity 1. Then it will be converted into 1 by a square plus x square. What is integral 1 by root of a square plus x square? Sin h inverse x by a plus c, or log mod x plus square root of x square plus a square plus c. So otherwise this without taking the x square quotient 9 as a common, we can proceed also like this with this. What I am doing is 25 is 5 whole square plus 9x is 3x whole square dx. Now if you take 3x as x, then it will become 1 by root of a square plus x square dx. So for the time being, let us take it as x. So then 2 I am separating from the process of integration. Now this is 1 by root of 5 whole square plus 3x whole square dx. Now this 3x, if you take it as x, then it will become 1 by root of a square plus x square. So integral 1 by root of a square plus x square dx is 2 into sin h inverse x by a. X is 3x by a is 5. Since this 3x I have taken it to be x, we need to differentiate. That is by d by dx of 3x. So that is by 3 plus constant of integration c. So this dividing with the 3 should not be forgotten, because again I am telling you, this is x. We have treated it to be x. Then actually it has become root of a square plus x square dx. Then this is sin h inverse x by a plus c. But here we don't have x here. 3x is there. So x quotient 3 we need to divide by d by dx of 3x. It is 3. So we used to do into d by dx of 3x in differentiation. Differentiation and integration are reversal process. Therefore by 3 we have to do. So therefore 2 by 3 sin h inverse 3x by 5 plus c, or you may write it as 2 by 3 into log mod x plus square root of. So 3x plus square root of 5 square plus 25 plus 9x square also. So what I mean to say is, so this is 2. Integral 1 by root of a square plus x square dx is log mod x plus, x is here 3x plus square root of this again. So 25 plus 9x square plus c by the quotient of x is 3 by 3. So this is also the another answer for this. Now the next question is 3 by square root of 9x square minus 1 dx. So 3, I am separating from the process of integration. 1 by this is 3x whole square minus 1 dx. So 1 also we can write it as 1 square. Now this is, let us take 3x to be x. So integral 1 by x square minus a square. Integral 1 by x square minus a square dx is cos h inverse. Therefore this is cos h inverse x by a. So 3x by 1 plus constant of integration c. Over sufficient? No. Since 3x we have it treated to be x, then only it has become integral 1 by x square minus a square cos h inverse x by a. Cos h inverse x is 3x by a is 1. So since 3x is treated to be x, we need to divide. By divide x of 3x. This is by 3. 3 gets cancelled. So cos h inverse 3x plus c, or we can write it as 3 into log mod x plus, so 3x plus square root of 9x square minus 1 by quotient of x is 3 by 3. So both answers are correct. So this plus c is this.